Hi, in this lecture, we will look at some of the programming languages used for artificial intelligence and machine learning applications. We are not going to look into the details of the languages as part of the lecture. We assume you have a fair understanding of these and some knowledge, or at least to a reasonable extent, are aware of their existence and uses. We will be covering the libraries and frameworks available in these languages that provide ready-to-use machine learning and artificial intelligence capabilities. Let us start with GNU Octave. GNU Octave, or commonly called Octave, is a scientific programming language. Out of all the other languages we cover in this lecture, it is possible that Octave is the only language you might not have heard of before. Octave is actually similar to the MATLAB language. In fact, many of the code snippets of Octave could be dropped into MATLAB scripts for running within MATLAB. Octave follows a mathematics-oriented syntax. This makes coding in mathematical models much easier, with the code being shorter and more readable. Octave comes with the built-in data plotting and visualization capabilities, making it highly suitable for data scientists. The programming interface is easy and can be quickly learned even by non-programmers. As you can see in the simple Octave program, we are defining a column vector called B, another vector called A, and then performing a matrix division of vector A divided by vector B. A simple program like this can help us solve a system for determining the value of x in an equation such as ax equals b. Here is another example of Octave where, using a simple program, we are plotting a two-dimensional graph. The first line creates an evenly spaced vector corresponding to the x-axis. The second line creates another vector y, which is the sine function applied on the values of x. The size of y will be same as the size of vector x. A simple call to plot x comma y creates a two-dimensional plot with x on the x-axis and sine of x on the y-axis. Additional functions can then be called to set a title for the graph and labels for the two axes. There are several types of graph that one can plot with Octave. This is just a simple example to give you a feel of the language. R is a highly valued programming language in the field of data science. It is not just a language, but a complete data science package. It comes with rich functions for implementing and testing several machine learning algorithms. Today, having a skill set in R is valued amongst employers, specifically if you're applying to any analytics role. R supports built-in plotting and visualization capabilities and generally meets end-to-end analytics requirements. New algorithms are added to R on a continuous basis. For training and testing any intelligent system, you need a reference dataset. R also ships with sample datasets. These datasets can be used for training and testing your machine learning implementations. Python is a popular language. It is a scientific language used for diverse requirements. Python is gaining popularity in the field of machine learning with the introduction of packages like Scipy and scikit-learn. Python as such allows for short, efficient, and powerful programs. The scientific nature of the programming language significantly reduces the boilerplate code and makes it more desirable for mathematical computing requirements, as in the case of most machine learning projects. The NumPy library makes mathematical matrix management extremely easy with built-in support for powerful matrix operations. Often, many machine learning projects require a lot of matrix operations. The Scipy package is a Python-based ecosystem of open-source software for mathematics, science, and engineering. Some of the core packages that make up for Scipy include NumPy, the Scipy library, matplotlib, IPython, SymPy, and Pandas. NumPy is an n-dimensional array package useful for matrices and matrix operations. The Scipy library is a fundamental library for scientific computing. Matplotlib is a comprehensive 2D chart plotting library. IPython is a package that offers an enhanced interactive console for data analytics. It also integrates with Jupyter Notebook and supports interactive data visualization. The SymPy package is a symbolic mathematics library. SymPy aims to become a full-featured computer algebra system, abbreviated as CAS or CAS. SymPy helps mathematical procedures simple, comprehensible, and easily extensible code. Pandas is an open-source Python library providing high-performance and easy-to-use data structure and data analytics tools. The name Pandas is derived from the term panel data, a term used for multidimensional structured datasets. The scikit-learn is a Python-based machine learning framework. It comes with several models that support out-of-the-box algorithms for classification, clustering, regression analysis, and even dimensionality reduction. If you don't understand what classification, clustering, regression, or dimensionality reduction is, then that is fine, as we will be covering these concepts later in the course. The scikit-learn package is actually built on NumPy, SciPy, and matplotlib. You would use Java for your machine learning requirements if you need a robust and highly scalable production deployment. It is more involved activity to create and deploy machine learning systems using Java, but once built, they can be highly scalable. Java comes with various libraries such as Weka, Mahout, and Deep Learning for J. The Weka Machine Learning Workbench is a modern platform for applied machine learning. It offers a graphical interface for building your machine learning algorithms. The GUI allows for development of machine learning models without the need for writing any code. Weka does offer CLI support, where all of the GUI functions are supported via a command line interface. The command line interface is very good for large jobs where scripting them would actually make sense. Weka is fully based on Java and open sourced under the GNU GPL license. It offers Java APIs that allow for smooth and seamless integration with your Java applications. However, the GNU GPL license requires that if you integrate Weka in your application, then your application should also be open sourced and licensed under GNU GPL. Pentaho Corporation holds the exclusive license to commercially offer the Weka platform for business intelligence in their own product. Apache Mahout is a scalable machine learning framework built in Java. It supports integration with Scala and several other products. Mahout is designed for ease of development of various machine learning applications. Along with promoting fast development of ML models, it also offers the ability to run them at scale. Mahout supports integrations with technologies such as Scala, Spark, H2O, and even Apache Fink. Deep Learning for J is a Java-based framework for plug-and-play deep learning. Deep Learning for J offers highly scalable, out-of-the-box deep learning capabilities. It supports and encourages distributed computing. Deep learning for J can be deployed on multiple servers in a clustered environment. The algorithms are designed for fast training and fast predictions by taking full advantages of its distribution capabilities. Deep learning for J is compatible with any JVM-based language such as Scala and Clojure. Keras is employed as deep learning for J's Python API. Keras helps bridge the gap between Java and the Python ecosystem. Scala is a functional programming language. It is based on Java but greatly reduces the boilerplate. The functional coding style makes the code more readable from a data science perspective. There are several machine learning models built on top of Scala. One of the popular ones is mlib, which is available within Apache Spark. There are also other libraries like Scala NLP and DynaML. Scala NLP offers natural language processing functions. DynaML offers several ML functions and is a Scala shell and platform actively used for scientific research. C or C++ is one of the fastest and lowest level languages available today. Often higher level languages like Java, Scala, or Python are chosen for ease of coding. However, when sheer performance is required, one has to go down to coding in C or C++. Several of the high-performance machine learning libraries are written in C or C++. Examples of C++ machine libraries are Shark, Waffles, dlib, plearn, and MLC++. We are not going to go into the details of these libraries. Many times it is advisable to build your algorithms and test them on higher level languages such as Octave, R, Python, or Scala. Then when you have to put them to production and need higher performance, you can choose to run the same algorithms on equivalent Java libraries or any of these C or C++ libraries.